This is the video for 10-5 solving quadratics with the quadratic formula. Nice thing about the quadratic formula, it is given to you on your reference sheet, so it's not something you have to memorize. It'll kind of just be there for you. Another nice thing about it is you can use the quadratic formula with any quadratic you want. So if you ever got to an exam question and you weren't really sure which method to use to solve that quadratic, you could always resort to using this formula. So it's x equals negative b plus or minus the square root of b squared minus 4ac, and that's all being divided by 2a. The way that we get our a, b, and c values that we're going to plug into that formula is by getting the quadratic into standard form. A is going to be the number in front of x squared, b is going to be the number in front of x, and c is going to be your constant. Once you know those values, all you do is plug it in, and then you're just going to simplify. Now with quadratics, like I've said in the past, normally you're going to get two solutions out of it. And the way that we get our two solutions is because of this plus or minus symbol in front of the square root. The reason that there's a plus or minus symbol there is because when we take the square root of a number, let's say for example the square root of 25. Many of you would say the square root of 25 is 5. And that means that I can take 5, I can square it, and that will give me an answer of 25. Now the way that we get the minus or the negative version of that is by saying, well, if we also square negative 5, we are going to get an answer of 25, because a negative times a negative gives you a positive. So that's why there's that plus or minus symbol there. So taking a look at number 1, whenever you are trying to find your a, b, and c values, you just have to make sure that your quadratic is in standard form. If it's not, you're probably going to get the wrong a, b, and c values. Number 1 is in standard form, so I'm going to go ahead and start listing those out. So my a value, the number in front of x squared, even though we don't write it there, it's a 1. B value, number in front of x, is going to be negative 3. And the c value, the constant, is going to be negative 10. Just make sure you're always looking to the sign in front of each of those values. Now once we listed out our a, b, and c values, all we have to do is plug it into the quadratic formula. So that's going to give us x equals negative b. Negative b means take the negative version of your b value. Our b value is already negative, so if we take the negative version of negative 3, it's just going to be positive 3. Plus or minus the square root. B squared, negative 3 squared. And I'm going to make sure I put that negative 3 in parentheses so that when I type this into my calculator, it's squaring the negative and making it positive. Minus 4 times a, which is 1, times c, which is negative 10. And then we're dividing all of that by 2 times a, which is 1. From here, what I want you to do is I want you to evaluate everything under the square root symbol. You can type that whole thing into your calculator, but what I don't want you doing is I don't want you typing the square root symbol into your calculator yet. So go ahead and type in negative 3 squared minus 4 times 1 times negative 10 into your calculator. You should be getting 49. So we're going to rewrite this as 3 plus or minus square root of 49. And then I'm also going to evaluate this denominator. 2 times 1 is just 2. Now we can simplify this a little bit further by saying I know that the square root of 49 is 7. So that'll be 3 plus or minus 7 divided by 2. Now your last step for this is that you want to take your one solution that we have right now and just split it up into two solutions. One of your solutions is going to get the positive from here, the other is going to get your negative. So it's going to look like x equals 3 plus 7 divided by 2 and x equals 3 minus 7 divided by 2. Last step here is just to evaluate each of those x values, each of those solutions. 3 plus 7 gives me 10, divided by 2 gives me 5. And then 3 minus 7, negative 4, divided by 2 is going to give us negative 2. Okay, so those are my two solutions. If you look at the picture of the graph here, if we were to zoom in a little bit and get a bit of a better picture of that, we would see that it would cross the x-axis at -2 and +5. So since we got two kind of nice answers here, didn't run into any decimal points or anything, this one has two rational roots. So I just want you to label that above your graph. On to number 2, x squared minus 5x plus 5 is already in standard form, so I'm going to list out my a, b, and c. Oops. B and c. A is 1, b is -5, c is 5. And then use that quadratic formula at the top of this page to plug a, b, and c in. So we get x equals -b is going to become +5 plus or minus the square root b squared minus 4 times a times c all over 2 times a, which is 1. And again, those values are coming from the number in front of x squared, the number in front of x, and then our constant. I'm going to go ahead and evaluate what is under the square root symbol. If you put all of that into your calculator, you do end up getting 5 under the square root symbol. And then evaluate the denominator. 2 times 1 is just 2. Now, if you were to type the square root of 5 into your calculator, you're going to notice that you get a long, never-ending, never-repeating decimal. That's because the square root of 5 is irrational. And since the question is not specifically asking us to round anywhere, you actually don't want to do anything further with this answer. You can keep it just like this. You could also just split them up, one getting the plus, one getting the minus. It's not super necessary. But what you don't want to do, again, is you don't want to round that square root of 5 because the question doesn't say to round it. So if you look at this graph here, you'll see that it does cross the x-axis at 2 decimal points. They don't cross at an actual hash mark there, so you know it's going to be at some decimal version of a solution. So this has 2 irrational roots. So either answer will work if you keep it together or you do split them apart. On to number 3, x squared minus 6x plus 9. List out my a, b, and c because I'm already in standard form. A is 1, b is -6, c is +9. Then we're going to plug that into the quadratic formula. X equals -b becomes +6 plus or minus the square root b squared minus 4 times a times c all divided by 2 times a, which is 2 times 1. Go ahead and evaluate what is under the square root symbol. Should be getting 0. And then denominator 2 times 1 is just 2. Now if we take the square root of 0, that's just 0. So I'm going to rewrite this as 6 plus or minus 0 divided by 2. And then if I split this up, one getting the plus, one getting the minus, you're going to notice we're going to get the same exact answer. Because whether I take 6 and add 0 or subtract 0 and then divide it by 2, I'm going to get 3 as my answer no matter what. Okay, now if you take a look at the graph, notice how the graph does touch the x-axis at 3, but it doesn't ever actually cross through it and then come back up like the other examples that we've seen so far. So when you get kind of two solutions here that are the exact same number, this is called a double root. And it'll always look like this graph where it kind of just bounces off at that specific number. All right, next one, x squared minus 6x plus 10 equals 0. A is going to be 1, b is going to be -6, c is going to be 10. Let's plug that into the quadratic formula. X equals -b, +6, plus or minus the square root of b squared, so -6 squared, minus 4 times a, which is 1, times b, times c, which is 10, all divided by 2 times a, which is 1. And again, you do not have to remember this formula. You do not have to memorize it. It will be given to you on your exam. If we evaluate what is under the square root, so negative 6 squared minus 4 times 1 times 10, we're actually going to get negative 4. And then evaluate that denominator to give us positive 2. Now, if you try and type the square root of negative 4 into your calculator, what you're going to get is an error. And that's because we cannot take the square root of a negative number. It's called an imaginary number in math. That's a concept that you will learn probably in Algebra 2. But all you really need to know is anytime we have in the quadratic formula where we're trying to take the square root of a negative number, anytime you're kind of getting that error, there's going to be no real solutions here. Okay, and if you take a look at the graph, notice the picture of the graph, the line actually never crosses through the x-axis. We saw a question like this on one of our homeworks previously where it did not cross through the x-axis. We said if it doesn't cross through that axis, there's not going to be any solution. Okay, so I just want you to note on your notes that the reason for this is because we took the square root of a negative number. That's called an imaginary number. So there's going to be no real solutions or no real roots. I'm going to leave number 5 for you to try. Actually, I lied because it's just a little bit different. 3x squared minus 12x equals 0. This is in standard form, but notice that we don't have a constant here. That's okay. We're still going to fill in our a as 3. Our b in front of x is negative 12. And since there's no constant here, a constant is just going to be 0. Okay, so I'm going to leave the rest of that one for you to plug into the quadratic formula. Try that one on your own and then check the answer key, post it on Schoology. Moving on to just some Common Core questions here. Number 1 says, what are the roots of the equation x squared plus 4x minus 16 equals 0? Since we're talking about the quadratic formula, I'm going to go ahead and try and plug this into the quadratic formula. So my a is 1, b is 4, c is negative 16. I did list it here for you again. So x equals negative b, so negative 4 plus or minus the square root, b squared, 4 squared, minus 4ac, 4 times 1 times negative 16. And that's all being divided by 2a, which is 2 times 1. When we evaluate what is under the radical symbol, we get 80, so negative 4 plus or minus the square root of 80. And then evaluate that denominator, 2 times 1 is just 2. Now, if you try and take the square root of 80, you are going to get another long, never-ending, never-repeating decimal, which means that's an irrational number. Easiest way to handle this question, guys, is to split it up. Do not do anything with the radical yet. So 1 gets the plus, 1 gets the minus. And then from there, if you just type each of these into your calculator separately and kind of get the decimal version of it, you'll see that the first one comes out to be 2.47-ish. And the second one comes out to be around 6.47. Once you've done that, I want you to type each of these choices that they give you into your calculator. Do one with the plus, one with the minus for each of them until you get those exact same decimal points. Once you get the same exact decimal points, then you know you have your answer. I'm just going to skip through that part to save some time on this video. So let's go to number 2, the zeros of the function x squared minus 2x minus 24r. Again, since we're talking about the quadratic formula, I'm going to use that. obviously you have your factor and t-chart option of doing this here. You can graph this in your calculator and see where it crosses the x-axis, but we'll just get a little bit more practice with the quadratic formula. A is 1, B is -2, C is -24. Plug it into the formula. X equals -b plus or minus the square root b squared minus 4 times a times c, all divided by 2a. Once you evaluate what you get under the square root symbol, it is square root of 100 divided by 2. Square root of 100 is 10, so we can change that to plus or minus 10 divided by 2. And then finally, we're just going to split those up. One gets the plus, one gets the minus. So x equals 2 plus 10 divided by 2. X equals 2 minus 10 divided by 2. Here we get 12 divided by 2, which is 6. And -8 divided by 2, which is -4. So we are looking at choice 3. Oops. Number 3, how many real number solutions does 4x squared plus 2x plus 5 equals 0 have? You could plug this into the quadratic formula. I think the easiest way to do this, since it's a multiple choice question as well, is just to type 4x squared plus 2x plus 5 into your y equals into your calculator. Hit graph and see how many times that graph crosses through the x-axis. If it only crosses once, it only has 1 0 or 1 solution. If it crosses through twice, it has 2 solutions, and so on. So pause the video, type that into your y equals, see how many times it crosses through the x-axis. Hopefully you saw that this does not cross through the x-axis at all, therefore it's not going to have any real solutions or real zeros. Okay, so that answer is choice 3. Now number 4, solve the equation algebraically for x. We're going to use the quadratic formula here, but notice we're not in standard form. Okay, this 7 on the right hand side is throwing me off. I like that right hand side to say 0. So to move that 7 to the left hand side, we do have to subtract it. Remember, you have to do some sort of operation. You cannot just kind of plop it to the other side. Okay, now that I have it in standard form, I can list out my A, B, and C. A is 4, B is -12, C is -7. And then finally, we're just going to put that into the quadratic formula. X equals -b, so that becomes +12, plus or minus the square root, b squared minus 4 times a times c, all divided by 2 times a, which is 4. Go ahead and evaluate what is under the square root symbol as well as your denominator. We end up getting 32 under the square root symbol and 8 for your denominator. Now, if you take the square root of 32, 32 is not a perfect square, so you're not going to get a whole number there. So you can actually just leave your answer just like this. Do not try and round the square root of 32. Nowhere in the question does it say to round, so you just want to leave your answer like that. Okay, last one, number 5, solve algebraically. Again, we are not in standard form, so I'm going to subtract that 180 from the right side to the left side. Now notice here we don't have any x term, which means we're not going to have a b, but that's okay. We're going to carry on. So a is going to be 5, no b term, and my c is -180. Plug that into the quadratic formula. X equals -b is just 0, plus or minus the square root. 0 squared minus 4 times a times c, all divided by 2 times a, which is 5. under the square root symbol, we end up getting, so since I'm doing 0 plus or minus, I can just get rid of the 0 and just keep the plus or minus. I end up getting 3,600 divided by 10. If you take the square root of 3,600, you do get 60. So one x value is going to be positive 60 divided by 10. The other is going to be negative 60 divided by 10, which is going to give us 6 and negative 6. Okay, next page of the notes is your homework. Remember, you're not required to submit the homework, but wouldn't be a bad idea to maybe just try a question or two and check your answers to that on Schoology under the Unit 10 folder in the Homework Answers folder.